On this month's Sky at Night, we'll be taking you to one of the most spectacular and fascinating places in the whole night sky.
It's officially known as M51, but most of us know it by its more romantic name, the Whirlpool Galaxy. M51 is a stunning sight, but it's more than just beautiful to look at. It is also one of the most fascinating places we have ever discovered. Its sculptured spiral arms are a maelstrom of star formation, lit up by the light of hot young stars. But it is also a stellar graveyard, in which we can see neutron stars and black holes tearing other stars apart.
So why is this galaxy so active? And how did it get its majestic and surprisingly prominent spiral shape?
Welcome to the Sky at Night.
We're making this Whirlpool Galaxy Day. On this one day, we're going to be pointing as many telescopes as we can at the object. We've got amateur backyard telescopes, professional instruments like the dish behind me, and on mountaintops around the world, large observatories, several of which have got better weather than here in Cambridge.
We'll even be going above the weather because we've got special permission to use one of NASA's space telescopes. We'll be looking at M51 at different wavelengths of light and different magnifications to create a unique portrait of this remarkable galaxy.
We've come to the Mullard Radio Astronomy Observatory just outside Cambridge. Founded in 1957, it helped pioneer a completely new way of observing the sky. It was here, well actually just over that hedge, that Jocelyn Bell discovered the first pulsars. And later on, we'll be using some of the modern instruments that still operate on the site to take a close look at the Whirlpool Galaxy. But our exploration of M51 doesn't start in this slightly damp field. It starts somewhere with much clearer skies. It's 9 o'clock in the morning. It's a terrible time to be trying to observe a galaxy, at least from here, but this laptop is connected to a telescope in Hawaii where it's still dark. It's a 0.4 meter telescope on top of the island of Maui on a dormant volcano, and you can see from this camera just outside the observatory that they've got brilliant clear skies. You see a couple of planets, the nice Milky Way, and this region of sky where M51, our target, is located. Now the telescope's already slewed to the source and it's taking a 5-minute exposure. And so in just a few minutes we should see our first image of the Whirlpool Galaxy. Well, there it is. This is our image, and you can see immediately the spiral arms in the galaxy which wind round this central bright nucleus. And then the second thing you notice is that there are two galaxies in the frame. There's this companion which has stretched out this bright material from the main galaxy, so you get this arm joining the two, and there's lots of faint gas and dust around that secondary galaxy. And really that's what the Whirlpool Galaxy gives us. It's a chance to watch a collision between two galaxies in action. It's something we can't see this well anywhere else in the sky. It really is a beautiful image. Maggie showed this image to galaxy expert Rob Kennicott to ask about the Whirlpool's amazing structure and its relationship with its companion.
It is absolutely wonderful. So those two spiral arms, they look almost perfect. The classic spiral galaxy. So how are they formed?
Almost all disk galaxies like this system do have spiral structure, but as you say, these are spectacularly prominent arms, and we're quite certain now that to produce such strong spiral structure, you need the driving force of an interaction with a companion galaxy.
Now, you see, to me, that seems counterintuitive, because when I think of collisions, I think of chaos, things being thrown everywhere. I don't think of structure being formed that way.
I agree with you, it's not intuitive, but this computer simulation is designed to show how these collisions between galaxies can excite spiral structure. So you have two galaxies, disk galaxies, much like the spiral.
So it's looking a bit messy now, but wow. You see actually the spiral forming due to the collision, and in both galaxies. So, but in this simulation, we had two similar-sized galaxies. What if you had something that was more akin to the Whirlpool galaxy?
Well, what we have here is a second computer simulation, and this one is actually specifically tailored to try to reproduce the two galaxies in the Whirlpool system.
Right.
So this kind of spiral structure you see in the beginning is actually the sort of spiral structure that is common in galaxies like the Milky Way. So even before the interaction, Whirlpool probably was a spiral galaxy. But now you see the companion making its appearance.
Now, that doesn't look like a companion galaxy. It looks more like a point mass.
I think that's right. To save on computing time, I think they modeled the companion galaxy as a point mass. And now you're beginning to see its effects already. The spiral pattern is being amplified. And let's keep going. And there you are, I think.
You've got the two distinct spiral arms, and you've got the companion galaxy at one of the ends of the spiral arms. So that is a good recreation of the Whirlpool and its companion.
But notice this is 300 million years after the start of the calculation.
Yes.
But you think of this as now in our world, right? So now the computer is going to predict what this system will look like in the future.
The future of the Whirlpool galaxy.
Indeed. So as you see, the companion continues to get closer and closer to the center of the spiral. It's still on the way in. And as it goes, the spiral arms are amplified even more than today, if that can be imagined.
But it's getting a lot messier.
Indeed. It's now reached closest approach, and on the way out, it's leaving kind of a train wreck behind. And now you see the companion is coming in for a second time, and the movie stops at this point. But if we were to continue it, the two galaxies would totally merge together.
But that means that the Whirlpool galaxy, in all its perfection as it looks today, is transitory. So it will pass through that phase, and at some point end up maybe more like this.
Yeah, indeed. And look at the scale. In about 70 million years, that phase of spiral structure will be long over. And you'll be left within 100 million years with one galaxy where there were two before.
So it just makes me appreciate the Whirlpool galaxy all the more, because we can appreciate its beauty right at the moment, but it won't last.
Indeed.
The telescope in Hawaii actually took 3 pictures of the galaxy, each at a different wavelength. When composited together, they give us a colour view of the Whirlpool in all its glory. But it's not just professional telescopes that can capture spectacular images like these. Pete has been trying to demonstrate how you can view the galaxy for yourself. And he's been exploring the history of our observation of this galaxy.
Astronomy in the UK can be a bit frustrating at times, and the clouds have now come in, and I really don't think I'm going to get a view of M51 tonight. So welcome to the Great British Summer. It really is a pity that it's cloudy this evening, because M51 is one of the best deep sky objects up there. And at the moment, it's really high up in the sky, which means it's well away from any murk close to the horizon, and that will give you a good view of it. And it's pretty simple to find too. To locate it, first identify the plough, or saucepan, which is part of Ursa Major and is one of the most recognisable patterns in the entire night sky. Identify the star in the middle of the handle and the one at the end of the handle. Draw a line between them and turn by 90 degrees and move for about half that distance again, and that'll take you to exactly where M51 is in the sky. You can't see M51 with the naked eye, but it is possible to see it with just a pair of binoculars. And if you've got a telescope like this, then it looks quite amazing. And that will also allow you to take a picture of it. And I've got a picture here I took a little while ago, and you can really start to make out some of the structure of the galaxy. You've got the spiral arms, they're very evident there. You've also got the little satellite galaxy as well. That's very obvious. So if you can get a view of M51, it's a really rewarding object to have a look at. But not everyone has always thought that M51 was fascinating. The Whirlpool galaxy was discovered by Charles Messier in 1773 and added to his famous catalogue as the 51st entry, hence the name M51. But Messier wasn't interested in how fascinating M51 was. He was a comet hunter, irritated by wasting his time pointing his telescope at things that superficially resembled comets, but which on closer inspection were revealed to be something else entirely. So he set about making a catalogue of what were to him frustrating objects so he could ignore them in his search for comets. But the irony was that in doing so, he had compiled a list of nearly all of the most spectacular deep sky objects. Nebulae like the Orion Nebula, open star clusters like the Pleiades, and galaxies like M51. To be fair, Messier probably couldn't resolve the Whirlpool to be much more than an indistinct diffuse cloud, a nebula. The first time the Whirlpool galaxy was seen in all its glory was in 1845, when William Parsons, the third Earl of Ross, pointed a 1.8 metre reflecting telescope based in Burr Island, which was then the largest telescope in the world, at M51. And this is a sketch he made of that object. And it's absolutely incredible. There's so much structure to see here. But what's really evident is the spiral nature of the galaxy. And that was the first time this had ever been recorded in a celestial object. The picture was quite a sensation at the time and was published all over the world. It's even suggested that his swirling drawing was the inspiration for Van Gogh's Starry Night. But we still didn't know what the Whirlpool was or where it was. And it was only in 1924 that Edwin Hubble demonstrated that nebulous objects like these were in fact distant galaxies in space. We now know it's about 30 million light years away, and although much smaller than the Milky Way, the disk is huge, measuring 60,000 light years across.
Images like these, taken by Sky at Night viewers, clearly show why M51 is one of the most exciting places in the universe. But they cannot show us many of the secrets that are hidden deep within those spiral arms. To reveal those secrets, we need to find different ways to look at the galaxy.
These dishes are radio telescopes. They're just a receiver, not too dissimilar to an FM radio, but they're much, much bigger. That's because the signals they're trying to pick up from space are absolutely minuscule.
In fact, it has been calculated that if you add up every radio signal ever picked up by all the radio telescopes in the world, the combined energy of that radiation will be enough to melt just 3 snowflakes.
These telescopes are actually lining up right now to come in line with M51, the Whirlpool galaxy, which lies around 30 million light years away in that direction.
These are the radio images captured by the Mullard Observatory dishes. Superficially, these pictures are not as impressive, but they show details that we could never reveal with conventional telescopes. The result of intense magnetic fields and the glow of hot gas around young stars. And this remarkable image from the Very Large Array Radio Telescope in New Mexico reveals the distribution of hydrogen throughout the galaxy, the raw material taken for us by the Liverpool telescope just last night. Actually, it's 2 images because the galaxy doesn't fit on a single frame. What we can see in this image is light from more stars than we'd otherwise see in the visible. By using the infrared, we're able to peer through the dust that would otherwise obscure our view. But this is an image in the near infrared. We're only just past the red in the visible, and we can go further than that. And the colour here represents the different wavelengths of infrared light. And you can immediately see there's a difference between the 2 galaxies. The small companion galaxy is bright blue, and in this image, blue light comes from old stars. So this galaxy has an old stellar population. There's not much going on there right now. In contrast, the Whirlpool itself has this brilliant red glow. That's light from the dust and gas, the fuel of star formation, which you can see is spread throughout the disk and has this wonderful structure, not just the spiral arms, but these filaments and these spokes in the disk as well. But if you look along the spiral arms themselves, and only on the spiral arms, you see these bright knots, these bright blobs that are shining very brightly. And these are nebulae. They're places where thousands of stars are being born, and it's the light from those young stars that's causing these blobs to glow quite so brightly. We have similar features in our own galaxy. Places like the Orion Nebula, where stars are still being born today. But this is happening on a much grander scale in the Whirlpool galaxy. Each of these bright dots is a stellar nursery 100 times bigger than the Orion Nebula. These are all signs that the spiral arms in the Whirlpool are active, very active. So what this tells us is that it's not enough to have the raw materials for star formation. There's dust and there's gas throughout the disk, but it's only when it gets twisted up into these spiral arms that it can become dense enough to form stars. The spiral arms are where the action is. But to find out what's actually going on in there, we're going to need yet another way of looking at the galaxy, and to use a very, very special piece of kit.
Radio waves and infrared are both from the lower energy end of the electromagnetic spectrum. But we can also pick up higher energy radiation. Radiation in the ultraviolet and X-ray bands of the spectrum.
They're both familiar to us. X-rays can penetrate our skin and flesh, but not the bone, and that turns out to be really useful medically. UV rays from the sun are powerful enough to damage our skin. That's what causes
You're falling down onto that black hole, and the gravitational energy that it picks up as it falls onto that black hole, the friction as it moves against the rest of the material falling onto the black hole and orbiting it in this accretion disk, makes that material so hot that it starts glowing in X-rays.
The black hole at the centre of M51 is affecting its surroundings. We can see that in this remarkable picture of the galactic core, showing two donut-shaped rings of dust surrounding the black hole. But the Swift image also shows many other sources of X-ray emission, places where we must find equally extreme conditions.
Mostly these are going to be binary stars in the galaxy, but very special binary stars. One of the pair will have come to the end of its main sequence life, gone supernovae, and either turned into a neutron star or a black hole, and managed to do that without completely disrupting its companion. But the companion then gets close enough that it starts losing material onto that black hole or neutron star, which spirals around it in an accretion disk, and all of the energy that it picks up makes it incredibly hot, and so starts glowing in the X-ray. And so you see stellar death, really, in this image.
And so from Swift, you might be forgiven for thinking there are just these few interesting sources, but I've got another X-ray image, this one from Chandra, which is a larger and more sensitive X-ray telescope. And here you see not just the individual points, the X-ray stars that we were looking at, but now there's this purple glow as well. What are we seeing there?
This is hot gas, but not tied to individual stars. This is now hot, shocked gas in the spiral arms. And it's actually revealing the physics which is starting the star formation in those spiral arms. The compression of gas being driven very quickly from supernovae or winds from hot stars, shocking it and causing star formation to start.
Really, just seeing this glowing is evidence that this is a dynamic place. What's driving those changes?
The whole structure is driven by this companion and the interaction with this companion, and the timescales there are hundreds of millions of years. So it did its last pass about 100 million years ago, and a few 100 million years from now it's going to have merged completely with the Whirlpool galaxy.
It's a strange thought, isn't it, that it's going to change quite so utterly, and this familiar shape will disappear. I suppose we're just lucky to be able to see it while all of this is going on.
This is the beauty of modern astronomy. By using all the tools available to look at M51 in different wavelengths, we can reveal the secrets of the Whirlpool galaxy. We can understand its past and its future. The optical wavelengths show us light from just some of the stars in the galaxy. Radio reveals the distribution of gas, and infrared the clouds of dust from which the stars are made. UV light detects the hot young stars formed from that gas and dust. And X-ray emissions pinpoint what happens to those stars when they die.
And all these processes are concentrated in the spiral arms, dense waves of material created by the collision between the Whirlpool and its companion galaxy. All this information allows us to build a portrait of the galaxy, one that reveals it in all of its beauty and complexity. And isn't it amazing to think what else may be going on in M51? Around those stars, there must be planets. But is there life? Or even other civilizations looking back at us?
Thanks to everybody who contributed images for tonight's programme. But if you want to do some more astronomy, even if you don't have a telescope, we're letting you participate in some live research. All part of the BBC's Do Something Great season. Because we want you to become comet hunters. We need you to take part in an exciting project searching for a new population of comets hidden in the asteroid belt. It's run by Meg Schwarm. Hi, Meg.
Hi.
Now, you're one of the lead scientists on this project, but can you tell me, why are you hunting comets?
Well, we're looking for a unique type of comet, and these are really wolves in sheep's clothing. So these are asteroids that start looking like comets. So when you think of traditional comet, you think of an icy body coming in from the outer solar system and heating up and sublimating its ices off. But these are very different. So these are typical, plain, ordinary asteroids sitting between Jupiter and Mars. And when we occasionally look at these objects, we start to see that they have tails, like in this image here, where you see this dust tail, very similar to what you see with a comet, but that's still an asteroid.
So what do you think is causing this?
We don't know what the dominant mechanism is, but one source is water ice, which shouldn't be there. But it could be buried water ice underneath the surfaces of some of these asteroids that somehow gets exposed.
So why is this of scientific interest? The fact that we have these comets and they could potentially contain water.
Well, water is important for life, and one of the interesting things is to wonder, where did Earth's water come from? And we don't fully know, and potentially there's now a new source of water ice that could have been deposited on the Earth early on. And so understanding where these main belt comets originally came from, how did they get into the asteroid belt, and how many of them are there, might tell us about whether or not this could be a source for Earth's water.
So the point of the project is to find many, many more examples, hopefully. How can our viewers help?
Well, you can go to comethunters.org and get started right away. All you need is a web browser and your eyes.
So what does the website look like?
So what we're showing is 2 images of the asteroid, taken at 2 different times during the night. And what we want you to do is use your eyes to spot the tail. Human beings are really good at spotting patterns and things that don't match. And so we need eyeballs of anyone who wants to look, and the viewers for The Sky at Night, to help us, because you are better than a machine at finding these. This is your chance to be able to help discover a comet.
Well, you've convinced me I want to go and find a comet, so thank you very much. If you want to get involved, the website is on the screen right now. So good luck and happy hunting.
That's all for this month, but when we come back next month, we'll be reporting from NASA's Jet Propulsion Laboratory as the Juno probe arrives at Jupiter.
Until then, get outside and get looking up.
Good night.
Professor Brian Cox is looking at stars and their origins with Wonders of the Universe here on BBC4 tomorrow night at 10. And still to come here on BBC4 tonight, Storyville meets cycling's fallen idol in the Lance Armstrong story.
Good evening. For this programme, we're going to go right out to the edge of our known solar system. Beyond Jupiter and Saturn, there are 2 more giant planets, Uranus and Neptune. We call them the ice giants, because they're very different from the 2 gas giants, Jupiter and Saturn. With me, 2 experts, both from Oxford, Dr. Lee Fletcher and Chris Linthorpe. Can I of course you leave? So what are the main differences between the ice giants and the gas giants?
In fact, we knew very little about the ice giants before Voyager 2 flew past in the late 1980s. Voyager flew past Uranus and saw a greenish disk with very little cloud activity taking place over the disk itself.
It was a really boring planet. Let's be honest about this.
Well, lots of scientists looked at it and were quite disappointed. We were used to Jupiter and Saturn and seeing incredible storms and banded systems.
You didn't see storms and rings there.
We saw
there, but we didn't see them.
And in fact, that's been revealed over the last 25 years since Voyager 2, is that we've got a large data set of Hubble Space Telescope and ground-based observations of Uranus, which show that we simply flew past at a rather boring time. And in fact, it's become a lot more active now with white spots, incredible collars around the North Pole and the South Pole.
Uranus and Neptune are twins. They're dissimilar twins. Why?
Well, Voyager 2, when it flew past Uranus, gave us an idea what we thought an ice giant should be like. When we got out to Neptune, we realised that those ideas were again wrong, because Neptune has its own source of internal heat. It emits out more energy than it's receiving from the sun. And that emission of heat is driving a really complicated weather pattern. We see incredible storms, such as the Great Dark Spot that was present in Neptune when Voyager 2 flew past in 1989.
We haven't got that with Uranus. Apparently there's little or no source of internal heat. Why not?
Well, this has got something to do with the dim, distant past of our solar system and the way in which the ice giants formed in the first place. Something back in Uranus's distant history must have changed the planet into its present inclination.
Because it's really weird.
It's
right?
extremely
We haven't
strange.
mentioned that yet.
And what we should say is that Uranus somehow has been tilted completely over on its side.
Exactly.
Now, the Earth and Neptune, in fact, have a tilt of about 23 degrees, 26 degrees for
So,
Neptune.
if this is the Sun and this is the Earth, then you orbit...
It means that the
There you go.
planet is rotating like
That's
this.
right.
So it suffers from spring, summer, autumn and winter in the same way as the Earth does. Uranus, on the other hand, has got such an extreme tilt that it spends many, many years with this one pole of the planet facing towards the Sun. And in fact, when we flew past in 1986, the south pole of Uranus was pointing straight back towards the Sun.
What do you mean by the South Pole?
The South Pole has been defined by the International Astronomical Union as being the pole which we flew past.
Yes, so stop being
time.
awkward. The point, another point.
Point taken.
There's another critical point here as well. So if this is our Uranus and the planet's spinning like this, all the moons are in line with that axis as well. So why do people think this has tilted?
It can't be invalid, surely.
Well, one of the most popular theories out there today is that something in the distant past hit Uranus.
A large
it's
impact,
planetesimal.
in fact.
Some kind of large impact.
Where is it now?
Where the impact would have melded the two planets together such that what we see as Uranus today is the agglomeration of multiple impacting bodies.
You don't sound convinced.
I'm not.
So how would you do it? How do you tilt Uranus?
I wonder the age of planetary migration, interaction with Uranus and the other giants, and gradually tilted it over.
Well, during the migrational period, there is a very good chance that collisions of this sort were happening. In fact, the motions of these planets is causing gravitational instabilities, and it's flinging material around all over the place.
So I have a silly question, which you were talking earlier about ice giants, Patrick, but we're not looking at ice, we're looking at gas.
Oh, of course.
So why do we call them ice giants? Why aren't they just more gas giants?
Because they're icy.
Well, yes, but where's the ice?
It's an important point, and it does confuse a lot of people.
Confuses
the reason
me.
we call these things ice giants is because the material that they're actually made of, planetary scientists call ices. So these are things like methane, things like ammonia, and things like water that have condensed to form solids in the outer solar system. Now, these have all been incorporated into the interiors of these two ice giants, but even then, they're not ices as you would imagine water ice being.
But if I
something
plunged
cold.
through the atmosphere and stayed alive,
Yes.
would I hit a solid icy surface?
You won't hit solid surfaces. What you'll see is that these ices are slowly being pressure cooked. The pressure is so immense at the centres of these giant planets that the ices take on a very alien and exotic form. Okay, now in Jupiter and Saturn, it's hydrogen and helium which consists most of the bulk of these planets. And hydrogen takes on something called a metallic form.
Yeah.
And this metallic form is conducting, and that's where we believe we get the magnetic field of the giant planets from. Now on Uranus and Neptune, there isn't as much hydrogen and helium because there simply wasn't as much available in the outer disk when it formed. So the thing that gets pressure cooked are these ices that you're talking about. And those ices that are in a sort of molten fluid state within the interior, they are still conducting. So Uranus and Neptune do have magnetic fields, but even those are extremely odd. They're tilted and they're offset. There's a lot that we simply don't know about them.
It occurs to me, I mean, we talked about the Great Dark Spot a bit, and you now tell me...
We've come a long way, and thank you both very much. Uranus was discovered in 1781 by William Herschel to the Herschel Museum in Bath, and Paul Abel went there.
The Herschel Museum is in the heart of Bath, and this beautiful Georgian house was once home to the great William Herschel and his sister Caroline. German-born Herschel arrived in England fleeing the Prussian War. He was penniless and made the spa town of Bath his home, earning his living teaching young ladies music. He brought over his sister Caroline to run his household, and together they became two of our greatest astronomers. Well, this is Herschel's piano because he was first a musician, then he became a rather prominent astronomer. And look at this is brilliant. This is a picture of the distinguished men of science of Great Britain living in the year 1807, and there's Herschel, right on the end. Wandering through the museum, you really feel Herschel's passion for astronomy. These are his original telescope eyepieces. Just think, Herschel would have looked through these to map the night sky. Herschel also made his own mirrors, striving to improve the magnification so he could see further into the heavens. Well, here we are in Herschel's workshop, and it's here that he made the telescope mirrors, not just for himself, but for other astronomers as well. And back then, of course, telescope mirrors were made of metal, and he'd take the blank, put it in this device, and spend many hours polishing the mirror to gain to the desired shape. And it's here that he made the telescope mirror for his famous 7-foot telescope, which is upstairs, the one which he used to discover Uranus. So let's go upstairs and take a look. Herschel was eventually to become famous for his enormous 40-foot telescope in Slough, but in Bath he had a more modest reflector. Well, here it is, a replica of the 7-foot telescope used by Herschel to discover the planet Uranus. And in doing so, he became the first person in human history to discover the existence of another large planet far beyond the orbit of Saturn, thus opening up the icy depths of the solar system to us. With the discovery of Uranus, the Herschels became overnight 18th century celebrities. The King and many others came calling. Jonathan Hall is one of the resident astronomers, helping to promote and preserve the work of William and his sister Caroline. Back in the 18th century, Herschel's nighttime activities were viewed by the good people of Bath as unusual.
His local reputation as being a little bit eccentric and very keen on the sciences and mathematics and optics, he would actually set his early telescopes up in the street, and the horse and carriages, of course, were obliged to go around him. He wasn't what today we might think of as a professional scientist. He was purely amateur, and he was building these telescopes with the aid of his brother and local craftsmen to arguably the best standard of the time.
Yes, and he made mirrors for many other people as well, many other prominent astronomers.
He did indeed, yes. Even in his youth, he started to read books on astronomy, read books on optics. He'd been teaching himself a little bit of Greek. He taught himself Italian and Latin, partly because of his music interests as well.
So much self-taught.
Incredible, yes, very tenacious. But it was really when he came to Bath that it really started to take off.
This is how the night sky would have looked on March the 13th, 1781. In the constellation of Gemini, there was an object which other eminent astronomers, such as Flamsteed and even Galileo, had overlooked. Herschel immediately knew that this was something special.
He wasn't actually looking for a planet. He'd only just moved back into the house. They'd been in a previous property. And in fact, rather unusually, he was on his own.
Because Caroline normally observed with him.
Absolutely. And he set the telescope up here in the garden, doing the systematic review of the heavens, and there trained it on the constellation of Gemini, and that's where he made the discovery.
And that brand new world needed to be named.
It did indeed.
So for a long time, people wanted to call it Herschel.
Yes.
He wanted to name it after his patron, didn't he, King George III? So in a lot of the old texts at the time, you can find it listed as Georgius Sidnus, George's
that's
star.
right, yes. I mean, Herschel, of course, was no fool.
No.
Patronage in those days, of course, was immensely important. And the other link, of course, is that King George III, part of the Hanoverian Empire. Herschel was from Hanover. So as part of the patronage, the king created a brand new post for him. He had to leave his life here in Bath, so he could be at the beck and call of the king and the royal family to actually then be able to go and show them the wonders of the heavens. And it's quite remarkable, over the 2 or 3 years immediately following discovery, all the eminent people from really literally around the world and from Europe who would actually come and pay homage and pay their respects and want to look, of course, through a Herschelian telescope.
The planet was eventually named Uranus, which in Greek mythology is the father of Saturn. It's in our night sky at the moment, in the constellation of Pisces the Fishes. It took some time to find it, but I made this drawing of it the other night. Herschel discovered this strange world over 200 years ago. It changed his life forever and guaranteed him a place in astronomical history.
Well, the Herschel Museum, well worth a visit, I can assure you, if you're in Bath.
Patrick, Herschel always makes me think of you, because of course he was a musician and an astronomer as well. And you've played some of Herschel's music, right?
I'm a very amateur musician. I've never had a lesson in my life, but we did a program about Herschel once, and I borrowed some of his music and played it on the air live on the piano.
Was it any good?
His music is.
Good. I wasn't asking about your piano playing.
I got through it. We've gone a long way now, so let's go even further out of the solar system and come to the Kuiper Belt, of which the most best-known member is, of course, Pluto.
Pluto is a very similar object to Triton in that it has over the surface ices of things like nitrogen and carbon monoxide that over the course of Pluto's extremely long orbit around the Sun will sublimate off to form a kind of atmosphere.
When it was discovered by my old friend Clyde Tombaugh, it was thought to be at least the size of Mars, probably larger, and therefore of planetary status. And we regarded it as a planet, and only has it been demoted.
It's been demoted, that's true, but I'm not sure it's particularly because Pluto's smaller than we thought. It's smaller than Mercury, but it's more that we found lots of other things this size out there.
It's not the only one.
So we had the choice of having 8 planets, as we do, from Mercury out to Neptune, or many, many, many planets. And we call those the Kuiper Belt, and Pluto-like objects are one part of it. Of course, the most exciting thing about Pluto is that there's a spacecraft on the way. New Horizons, which was planned, not that it matters, but it was planned while Pluto was still a planet, and a big part of their pitch was this was the last planet that we haven't seen.
Quite.
But where's New Horizons got to now? It's a few years away yet.
So it's still on its way to Pluto. It's going to get there in July of 2015, and it's just got past the orbit of Uranus. Now, it doesn't mean it visited Uranus, but it's on its way to do a slingshot by Pluto. And after Pluto, it's going to go on to look at another Kuiper Belt object.
Which hasn't been discovered yet.
No, it's something that we're still looking for at the moment as to where to go.
Right. Well, Pluto is interesting. It's merely the brightest member of the Kuiper Belt. It's certainly nothing more than that. There are plenty of others. And recently there was a big conference in France about these things. And Dr. Chris North went there and brings back news from the Kuiper Belt.
This year's annual gathering of planetary scientists in Nantes was the largest for many years. For space scientists, it's a great place to talk about missions to the planets, and for the astronomers, a platform to launch their new ideas. This year, the icy dark depths of our solar system have caused a bit of a stir. The Kuiper Belt stretches beyond Neptune and has previously been dismissed as the dustbin of the solar system, the leftovers of its formation. Meg Schwamb has been raking through the rubbish to find clues about the Kuiper Belt and its formation. We now know that there are lots of exotic objects out there. They come in a range of sizes, and some, such as Pluto, even have moons. While many formed in these icy outer depths, others formed closer in and were flung out there by the movement of the giant planets.
The Kuiper Belt really is the icy remnants left over from planet formation. Because you can think of it as the embryos and the failed planets that didn't form into the terrestrial planets or the cores of the giant planets and have been scattered out or may have formed out in orbits beyond Neptune. And so Pluto is one of the well-known and largest of these objects, and there are now many Pluto-sized bodies known in this region, as well as many hundreds of thousands of other smaller bodies that orbit in orbits well beyond Neptune.
In 2007, Meg discovered an object nicknamed Snow White, one of the largest Kuiper Belt objects at around half the size of Pluto. Despite its name, Snow White is actually red. The colour is caused by a tarry gloop called tholins, a term coined by Carl Sagan. We think tholins are methane and other chemicals broken down by weak sunlight over billions of years.
I mean, I don't think we've quite touched tholins in the outer solar system, but we think it's that if you take these methane ices and nitrogen ices and you keep irradiating the methane, you get higher and higher order hydrocarbons, and so you get more gunk and tar. Right. And so that's what we think it is, and we think it's reddens their surface, and so it's sort of this red crust or radiation crust sitting on the surface.
It's goo.
It's goo. It's sort of, yeah.
It comes from the Greek word for muddy, I believe.
I believe so, yes.
Kuiper Belt objects are the preserved remnants of our early solar system, and they tell us what it was like billions of years ago when the planets were forming. But studying it can be very frustrating, as the objects are so small and so very far away. Occasionally, however, we get visitors from the outer limits. Comets. Mike Ahern has led one of the most successful missions to not one, but two comets. In July 2005, part of the Deep Impact probe was smashed into Comet Tempel 1, giving us our first view of material from inside a comet. Following this successful mission, the Deep Impact spacecraft was rerouted, and in November 2010, flew past Comet Hartley 2, where it saw a very different world.
Every comet we've visited has been very different from what we would have predicted from the previous one we visited. So that's the reason for going to multiple ones, to try to find a pattern. One difference between Tempel 1 and Hartley 2, the two that Deep Impact spacecraft visited, is they're very different sizes and very different activity for their size. On Tempel 1, we saw differences in the outgassing from different parts of the comet. Now, right. Does this mean different parts of the comet came from different parts of the protoplanetary disk? It was hard to tell because
there was made of different stuff.
But there are strong seasonal effects on Tempel 1. Now at Hartley 2, it's in this excited state rotation where in addition to going around like this, it rolls, so everything gets illuminated all the time and there are no strong seasonal effects. And we still see big differences between the outgassing at the two ends, which says that they really must have come in the early solar system from different distances from the sun.
So they are different.
They really are different.
Comets, the archaeological remains of our early solar system, will help us understand how the planet Earth became such a unique world.
It's important because, for one thing, we think the comets bring all the water to Earth, or at least some of us have thought that all along.
Is that just because Earth's the only planet we know of with standing water on its surface?
Yes.
And the early Earth, that should have all boiled off, essentially.
Exactly.
So
exactly.
Where did it all come
So
from?
it has to have been brought in at a somewhat later stage, for only 500 million years after the formation, but
a long time ago.
Yeah.
The Kuiper Belt is clearly not the dustbin of the solar system, and the exotic objects that live there are far more than just rubbish thrown out during its formation. Instead, each one is a fascinating world, and the more we find out about them, the more we find out about our own origins.
Well, 10 new nights this month, so we'll go out now to Bristol from France, and of course, Lintop. Well, huge storm going on Saturn.
Well, a huge storm that's been going on for most of the last year that was discovered last December as this white spot, which is the form storms on Saturn normally take. But then this one spread out until it covered quite a lot of the disk.
A huge thing.
You can see it in these new images that we've just got from Cassini, though they were taken over the last year. And of course the amateurs saw this as well. And then they saw the storm fade over time, and it seemed like all was quiet on Saturn. But if you talk to the professionals who can use some really big telescopes and they can look in the infrared, they see that actually what's happened is up in the top of Saturn's atmosphere, up in what would be the stratosphere, there's still a lot going on. The storm now covers about a quarter of the disk, so all of the northern bit you can see on one side of the disk. But as it emerges in January, I think we're going to see some really interesting things happening where this storm was last year.
I wonder what we'll see.
Well, we'll find out.
Well, tying into Jupiter, and the second moon there, Europa. Interesting news.
Well, Europa is this moon that's got the very weird terrain. We call it chaotic terrain. And it was terrain that the Voyager probes in Galileo saw covered in cracks and fissures and all sorts.
Mapmaker's nightmare.
Yeah, indeed, a mapmaker's complete nightmare. And what we think is happening still is that that's cracked and broken up by the motion of a subsurface ocean beneath the icy crust. We can compare that to stuff we see on the Earth. And some of the features look like things we see in Antarctica with a subsurface sea, a subsurface lake, that's not quite that deep.
People are excited about this because it's always been my favourite idea for a mission anywhere in the solar system, which is you land on Europa and you melt your way through the surface, and then you see something with teeth coming towards you. Because the reason people care about this ocean is it's an interesting place to think about life.
It could well be.
Life on Earth, we think, started in deep oceans without much sunlight. So Europa's a fascinating world.
They all are. Well, of course, you can't get away from Mars. Always something new there. And, of course, this new probe, Phobos Grunt.
Yes, this was a Russian probe that was meant to go to the Mars's moon Phobos, collect a sample return mission, bring it back to Earth. Unfortunately, it made it into orbit. It's been stuck there. It's not sure what will happen, which is very sad.
Amazing. The Russians have never had any success there.
It was incredibly ambitious. It would have been the first sample return mission. But we shouldn't forget there's good news for Mars this month as well, which is that the American Curiosity rover is successfully on its way.
Liftoff of the Atlas V with Curiosity.
We're going to find out a huge amount about Mars's past and about whether there are the conditions for life there. So I'm really excited about Curiosity.
So far, all goes well.
We have spacecraft separation.
One more news, though. We found a long-lost Sky at Night program on a recording machine, and here it is.
Now, I'm talking about moon bases tonight for two reasons. First, because they are very topical, and we've just shown you one new design study. But secondly, because I'm delighted to have with me my old friend Arthur Clarke. Now, Arthur, you, of course, were forecasting developments of this kind, more than 20 years ago.
Well, thank you, Pat. And I'd like to begin with a flashback to the communications satellite which you mentioned by showing this illustration, which is of some sentimental interest to me, because I displayed this on BBC TV about 10 years ago. And this was undoubtedly the first time that anything about communication satellites appeared on TV anywhere in the world.
So, I mean, this is a programme from 1963, and to put us in context, that was before Apollo. Apollo was still in the planning. We'd had people into space, but only a few probes whizzing past the moon. And, I mean, Arthur C. Clarke was predicting not only these communication satellites, which were then starting to become a reality back then, but also was talking about bases on the moon, bases on Mars, all incredibly exciting for what we might do from then in the next sort of 20, 30 years.
Well, I think a great deal has depended there upon the question of the lunar atmosphere, because if the moon had proved to have anything of an atmosphere, then of course the surface dome would have been the answer. Do you think that this means that the lunar base has got to go underground?
Well, if it turns out that a meteor bombardment is a serious danger, then undoubtedly we will have to put our bases underground. But I rather hope that the necessity of a lunar underground movement does not arise. I hope we can stay on the surface and look at the stars.
So do I.
He and I are great friends. This is one of the few recordings we made together that's actually been preserved.
Yes, it's wonderful to see it again. I think if you could have picked one Sky at Night out of those that were lost, I think this one would have been high on the list.
I would agree.
Well, you can see more clips from it on the website, which is bbc.co.uk/Sky at Night, and I'm certainly going to go and watch it again and dream of Mars bases.
Well, thank you both very much indeed. When I come back next month, we're going even further and look at planets of other stars. Until then, good night.
Horizon is Seeing Stars, with a look at technological advances in stargazing, and that's over on BBC4 now. Here on BBC HD, stay with us for MasterChef The Professionals.